Hi everyone, so this is a video about the parts of a high quality CER, or as we're calling it this year, AEA. And this includes an L4 example that breaks down all the different parts. So the first part of a CER or an AEA is the claim or the answer. And this is the answer to the investigative question that was guiding your lab investigation. A claim typically restates the question in the answer in the sentence and doesn't include any explanation or data because all of that comes later. The E in both CER and AEA is evidence. And in science class, we specifically are looking for quantitative evidence most of the time, which is the data that you collect from the science investigations. And a full range of data that is representative of the class is important here. So if we ask you to pick, 3 or 5 of the averages for the class, that you're picking high quality data, not data that was made up, not data that seems suspicious, but is actually representative of someone's experience. The other thing to note about evidence is you don't want to include all of the trials that a group did. Averages are the best evidence that you can use. So the last section of a CER and an AEA is the reasoning or analysis section. And this is going to be the bulk of your writing because this is really where you explain how your evidence supports your answer. There are 2 types of reasoning or analysis. There's quantitative reasoning, which is where you explain your data, you explain the numbers you used. For students who are doing going further, eventually this will mean an additional calculation or statistical significance, but not yet. Then there's qualitative reasoning or analysis, and this really is the bulk of the writing because this is where you tie your answer and evidence to the science you've been learning in class. So this is where key concepts come in, vocabulary, and sometimes some outside research is necessary in this area. So this is an example. I'm going to pull out my highlight tool. This is an example of an L4 CER or AEA. And so the investigative question is at the top. So they were looking at how the type of habitat affects the soil moisture level. So this first sentence right here, you'll read it, sounds a lot like the question because it restates the question and then gives the answer. So the effect of the type of habitat on the soil moisture is that the more trees in the habitat, the more moisture there will be in the soil. No explanation, no evidence. It's a standalone sentence that answers the question and restates it. The next section where you start to see a whole bunch of numbers, this is the evidence section. They're listing what they call the mean, which is just another name for an average. And so they've got the average for the 3 different habitats. And so that's the evidence section, which makes everything else down here the reasoning or the analysis section. And if you just look at the size of the sections, you'll see that they put in the bulk of the work down here in the reasoning or analysis. So they do a little bit of quantitative analysis, evaluating the ranges of data, and then they start explaining the science. Now, they didn't have any key concepts to include, which is why those are missing from here, but they really are explaining how the evidence supports the claim. So if you're doing a mainstream version of a CER and AEA, this is an L4 example and this is all you have to include. So you can go ahead and stop the video. If you're doing a going further version, there's one more section that you have to add, and we're about to talk about that now. So if you're doing going further, you also need to include a discussion of error section. And this is where essentially you look for mistakes in either the design of the lab or in your in how you did the lab specifically, and then you evaluate one. So the mistake that you identify has to be what we call lab specific and reasonable. So it can't be a mistake or an error where it can be the same mistake or error in any lab. So if your error is, oh, well, we didn't follow the instructions, well, that's an error that can be applied to every lab. So it's not specific enough. And then an unreasonable error is something like, oh, well, we should have poured the water in the perfect location. There's no perfect location for any lab, and so that's not really reasonable. So after you identify an error, then you have to talk as specifically as you can about how this error impacted data. And I'll show you an example of this in a second. And then what you have to do is you have to explain a possible fix for the error. So here's an L4 analysis of error section. And again, I'm going to get out my highlight tool, which I apparently already have out. So the first thing that they do, is that they identify their error. So their error is that they were using a tool that broke and then they got a new one, but the new one was miscalibrated for them. So they started getting unexpected data. So they were getting, 1, 2.5, or 3 as their readings. And then all of a sudden with the new one, they were getting 7s, which is a big jump. So then what they do is they talk about how this impacted their data right here. It caused their mean to go up and to have an outlier, which is how it impacted the data. And then this last sentence here is them brainstorming or giving an idea of how that error could have been avoided in the future. So this is an example of an L4 analysis of error section. So I hope this video was helpful. Good luck writing your CER or AEA, and don't forget to bring any questions you have to class and ask your teacher. All right, thanks everyone.